Hey students, I wanted to talk to you a little bit about the graphing that you turned in. So I'm going to go through some of the good things that I saw and some of the not so great things because we're going to be doing graphing several times during the semester, and I want to make sure that you're getting the full credit that you deserve. So the first thing that you needed to pay attention to on these graphs is making sure your units were consistent. So at the top of the screen here, I have what was given to you if you did the Graphing Lab A. And so we'll notice that we have centimeters and inches in some places, and this was for the diameter. And then 2 columns over, I have the circumference, and some of them are in centimeters, some of them are in inches. So it doesn't matter a whole lot for this particular one, whether you go centimeters or inches, but in your labs, you're always going to want to go with the metric unit or check with your professor or TA. So in the next column over, I have done the calculations to get everything into centimeters. Now, something else you should notice is that the numbers are all over to the right-hand side when there is only a number, but they're on the left-hand side if there are letters in there. And Excel can't interpret that number if there are any letters in there, so you need to put it into just numeric form in order to see what's going on. Something that is good to pay attention to is significant figures. Our original numbers all had 3 significant figures, and once I did the calculations, those numbers seemed to change. And so we can change that by clicking on the box where it is, and then at the top under number, we've got some zeros with arrows. And so in this one, we want to have an extra 0. So it just worked out that it was 3.80, and Excel is just dropping that. It doesn't know that it's significant. You're smarter than Excel, so you have to tell it it's significant. The next one, we have too many digits, and so we can move that back by clicking on the other button. Oops. So that's going to get us the correct number of significant figures, and I can do the same thing in this column with my circumference. Okay, so I want to take a look at how the graphs would look different depending on whether I had my units all the same or had them different. So this is the way your graph should look. So we can see that we have everything falling on a nice line. Now, if you ever notice you have things that are mostly on a line, but one point is way off, and we'll look at another example of that later, then that's an indication that you probably did something wrong with that particular data point. You maybe entered it correctly, or maybe the measurement was bad. So if you can figure out what's wrong, fix it. If you can't, check with a professor about what you should do. So notice that we have a title up here, and then we also have the vertical axis is labeled both with what we're measuring and the units. And on the bottom, we have what we're measuring, circumference, and the units as well. Now, I've already added a trend line here. Is go to this plus, and it gives me the trend line. And when I click on that, I can decide what I want to do. So in this case, we're looking at a linear relationship, and so that works. Oops. Okay, so if I click on the trend line and right click, I can format the trend line. I can choose linear in here, and I can also select some options down at the bottom. So one thing that I can do is I can set the intercept. And so if I know that this is going to go through the origin, I can put the intercept, the y-intercept at 0. And it makes sense that if I have no diameter, I'd have no circle. So in this case, I might do that. There might be other cases where I would not do that. The other thing that I can do is to display the equation on the chart. So this is what the equation looks like with without having set that intercept. And then if I go back and set the intercept, because the intercept is 0, you'll see that that plus b portion of this gets chopped off. Okay, so if we pay attention to the slope here, whether we have the intercept or not is not really important. We are going to notice that the slope is about 3, and that is giving us more significant figures than we really should have. So we're just going to have to mentally keep in mind that we only get 3 digits here. There's not a convenient way of changing the display on Excel. If we look to the graph, we know the slope is the rise over the run. So it is the circumference divided by the diameter, which is an approximation of pi, or actually should give you exactly pi, but we don't have infinite digits here. So this slope then should be very close to pi. And we know that pi is 3.14159, yada, yada, yada. So this is very close to that. And that's what we're going to be using for the value of pi. Now, in most of the graphs that we're going to be looking at this semester, the slope is going to be very key to understanding the relationship between the values that are being measured. So we're going to pay a lot of attention to the slope. So now I want to take a look at another chart. If we have a chart that looks like this, this is what happens when I don't change the inches into centimeters or the centimeters into inches. I've got a mix of units, and so the numbers are just kind of all over the place. And this should be an indication that I need to go back and check those numbers. So that's what we need to pay attention to. And you'll notice that if I try and add a trend line here, it really doesn't go through any of the points. It doesn't really tell me anything very useful. So that's not very valuable. You'll also notice I'm missing axes titles and a title for my graph. If I go to this plus sign over here, I can put in, just check the box for axes title and then click over here to change the title. And I can also do a chart title, and it'll give me a space there to do some typing in there. If I have more than one thing that I'm graphing at the same time, so I've got basically 2 overlaid graphs, it's a good idea to have a legend. But if I'm only graphing one thing, the legend isn't really any more information than I already have, so I tend to leave that off. The next thing that I want to look at is the graph for C, for Lab C. Okay, so here we can see we have temperatures both in Celsius and in Fahrenheit, and here everything is in PSI, but some of them were written in scientific notation, some of them were not. So a couple of things we need to pay attention to there. So here I've written this in scientific notation. I didn't do the little caret with the 1 because I know 10 to the 1 is just 10. Remember that for Excel, you need to use the star for multiplication and not an X. And I can just stick an equal sign in front of this. So if I go up to the box where I type in, I can put an equal sign and it will give me those numbers already calculated out. So that's nice for those. But I don't have such an easy conversion for my Fahrenheit to Celsius. So on my 2 points where I have Fahrenheit, I've put in this formula. And so I click on the cell with the Fahrenheit temperature. And so it's highlighted in blue here as B22. I click on that. And then I use that for the formula. So I have to subtract off 32, and then I want whatever the result of that. So I put parentheses around the whole thing to be multiplied by 5/9. You cannot just put the number next to it. It will give you an error. So you have to do star 5 divided by 9. And so I've done that on both of those cases. And again, I've got too many numbers here. So I want to get that down to an appropriate number of significant figures for that. All right, so what I want to do is I want to look at what the data looks like here. Okay, so we can see that we have the vertical axis going through at 0. And in some ways, this is nice, but in other ways, it kind of makes that area hard to look at on the graph, particularly if we had data points in this range. So what I prefer to do is to move that axis to the outside and just know that I have these numbers here to tell me what the temperature is that I'm looking at. So what I can do is click on the x-axis. This is a little counterintuitive. When I click on that x-axis and format that, I can change where it crosses, where the vertical axis crosses it. So I can see that my last data point is just above -20. So I'm going to set the value at -20. And that's going to move my axis over. And so here I have two different sets of data. And so that's why I've got a legend over here. So when I have mixed units, I have things in blue. Now, these data points in the middle are the same for both of them. So the orange is kind of overlapping that. But I'm going to click on my blue and put in a trend line. I don't want a line connecting the dots. I want a trend line. And so I've got kind of a slant here, and you can see that I'm really missing a lot of my points by having it like this, okay? So that's a little bit awkward, and that's why we want to have it all in the same units. But I do have another problem if I'm looking at my data points that are in orange, that are in all Celsius, and I add a trend line. I've got this one data point that's really far out here. And so my suspicion is that even though on our data table, this was written as being in Fahrenheit, that temperature was actually in Celsius. Because if this were at 29 degrees Fahrenheit, that would be close to 0 degrees Celsius, and we would expect that data point to be around here somewhere, following the trend of the other orange data. So when we have a data point that's way off like that, and we check with our instructor first, we can't just willy-nilly do this. I'm going to say that data point is probably not right. So I am going to take that data point out, and we should see a change in our graph. So now the orange line is mostly going through these data points. We get a nice clean line there. And if we left this at the 29 degrees Celsius, we see that that fits very nicely there. All right, so another thing that I want to pay attention to is when you have your equation displayed on your chart. Now, this is an occasion where we don't want to set the intercept at 0 because we can have a pressure at 0 degrees Celsius. So we're going to leave that, that intercept in there. The other thing we can put on the chart is the r² value. And the closer this is to 1, or if it's a downward slope, the closer it is to -1, that tells us it's a better fit. And in chemistry, we want to have as many 9s here as possible because we don't have a lot of other influencing factors. Sometimes if we are doing something in the social sciences, because there's so many things that can kind of interfere with our experiment, from background and socioeconomic status and environment and all of those things, then we don't get these nice r² values. But for chemistry, they should be very, very close to 1. And so it's a good idea to display that on the chart as well, so that you are giving as much information as possible about the quality of your data. All right, so I am going to go and delete. Can I delete all of it? Yes, excellent. So I just want to see this one. Now, some of you pointed out that because we don't have as many lines as we would on graph paper, you can't really tell the values, but this is something that you can change on your settings. So what we can do is go to this plus sign again and look at the grid lines. So right now we have this box checked, but we also have So right now we have this box checked, but we also have a little arrow. So if we click on the arrow, we can click on primary, minor, and horizontal and vertical. And so that gives us a lot more of these lines that we can better tell where things are. And then you can have some even more options where you can decide what that's going to look like as far as how intense the lines are going to be and so forth.